code in now.
Okay. And as far as summary of the activity, continuing, our progress consists of tracking down some issues with the Redis database and our module configurations, and both Owen and I were able to get to the same step. So he has the server built on his machine with the time series module working. And on Grafana, we were able to import and modify the dashboard just with some sample data that they had on there, not yet with data from our server, because like I said, we're having that plugin issue. And on the electrical side, we were able to come up with a schematic and add some modules to it. Found a 24-bit ADC chip that supports the voltage and current inputs that we need, as well as found a photo transistor to convert the 24-volt AC to DC. And our CDR is scheduled for the 20th at noon. And for next week, obviously the most imminent thing is to diagnose and fix that Grafana plugin issue. And we'd like to meet up to discuss how we're going to use software to quantify and load the data into the database from the inputs on the RPi. We'd like to begin purchasing equipment as well as continue sourcing parts. And for required resources, the photo transistor and the ADC will need to be purchased. And I believe Nathaniel is going to handle that. And as far as potential obstacles, I really don't think it's going to be an issue, but I wanted to put it in here just to be forthright about it, is that Grafana plugin. And I'm going to go ahead and read through Nathaniel's accomplishments. So this week he was able to pick up the equipment from phase 2. He has it. We're holding off on looking at any of it right now because we want to be able to do it on our own. He started the PCB schematic. He found that ADC that can read the voltage and currents that we need. He found the photo transistor for the 24-volt VAC to DC conversion. He created the PCB modules for easily handling pieces of the circuit. And he also found more resources for communicating with SPI devices on Raspberry Pi. And for this upcoming week, he plans to continue looking into options for circuitry that can be used for I/O, finish adding all I/O to the PCB schematic, and needed support consists of purchasing the test boards as previously described. And at the moment, he doesn't have any questions or concerns.
Hello, am I clearly audible?
You are.
Okay, what I did this week is I implemented Redis and Grafana on a Raspbian virtual machine, which Raspbian is a Raspberry Pi version of Debian. I worked on synchronizing Redis and Grafana, the point where I've reached the equivalent point of William, and I'm sharing his problems. If you wouldn't mind going to the next one. This week, I'm going to keep working on Redis time series, keep working on Grafana, keep working on programming. I don't really need any support. And this is just more so I get a better idea of how the system in general should work. How is it being currently implemented in the devices being used right now?
Darsh, you want to answer that?
How is Redis implemented in current system? Is that what your question is?
Yes, but it's a little bit more general than that.
Okay. So how is the system currently implemented? As in, right. So we have our custom own database, CARR database. And in that, we have our own protocol, which is called, a CCN. Over that, we expose a lot of our data, which is normally logged at once per second. And it requires special hardware, and it adds, overhead of having special equipment on your hand. compared to, if we move to Redis, it's just Ethernet wire connected to the actual hardware, and we would be able to log the data, look at what's going on in the system. If our data if our database was on Redis compared to our carrier database, there are a few custom REST calls that we can make to get the data out of the carrier database, but Redis is very neat. So that's why we decided to go with Redis, and our future products will utilize a Redis database. So that's why we are encouraging and forcing you guys to use a Redis database and try to graph those things onto the actual hardware or connected device if you have. So that's the gist of.
Thank you very much, sir.
So what I did last week, I just worked with Nathaniel and Andy on the schematic. We added the modules in. We just basically created, blocks of modules that just kind of organized the whole schematic together. Added the ADC chip that looked very promising. It was able to collect inputs from the voltage inputs and current inputs, and it looks very promising because there's a mux inside that we can use to swap between which input we want to view, and hopefully we can switch between those and store the data that's coming in from the current and voltage inputs. We did find a DAC chip. It's the 1282. It only has one voltage output, so we might have to use multiple, but we're looking to see if we can find a better option with multiple outputs, so we can organize and not fill the circuit up with a bunch of DAC chips. We decided to use an optocoupler to read the AC voltage coming in from the digital relay, and that's just basically going to provide a DC voltage that'll go into the system. We did find some breakout boards and an evaluation board for the chips, but we still don't really know how to properly go about interfacing the chips and the Raspberry the Raspberry Pi. So we're gonna keep looking into that. For next week, we're gonna just keep looking into the chips and the chips that we found, as well as the breakout and evaluation boards, to see what the best way to go about that is. For support, for component verification, we just basically wanted to know if you guys thought that the chips that we found were good or were to your liking, basically, and for purchasing, that's more for Nathaniel and Dr. Gridizar.
Okay, we'll have to take a look at that when you guys send over the specs. We'll check out those parts.
Okay, gotcha. Yeah, I'll link it in the Discord for you guys. And for my main question is, how do you want us to go about soldering for components and stuff? You want us to solder it ourselves, or get a manufacturer to solder it?
I would say I guess if we have enough budget, then we should be able to, I guess, let other people, other company solder it for us. So just order the circuit, I guess. But I don't know how much the cost would be.
Right.
It depends how much budget is left, right? So
Gotcha.
And just to try and answer that from my end, if it really all depends on how large the PCB is and how large your components are. So if you feel like you can do it, you're more than welcome to try it yourself. But in our department. Eddie Hill has the really good soldering skills. So he's our lab person. So he could solder for you if need be. I don't know how many parts you're gonna need. So if it's like 100 parts, then I don't know if you could do that many. But it's all possible to also do it in house if need be.
Gotcha. Yeah, I think it should be I think it should be doable for us to solder it ourselves. I just wanted to know if that's something you guys wanted to think about in the future. Like soldering it manually or having a company do it, so we can look into that for you guys too. Yeah.
Generally speaking, we have our own board manufacturers. In the long run, anything that we decide to produce ourselves, well, we have manufacturing lines that have pick and place parts and all that sort of stuff. So for the scope of this effort, it's really just what's easiest for you guys and reduces your risks as much as possible. So
Gotcha.
work with Dr. C on what makes the most sense for your particular application.
All right, gotcha. Thank you.
All right, so last week I experimented with the Grafana dashboards, some graphs on it, and was able to mess around with the query system a bit, try and get some understanding of how we're going to make the graphs. I helped Owen get his Redis build set up on his machine just because I ran into a lot of the same issues that he had and was able to kind of jumpstart him on that. And I've been working on diagnosing that failing plugin health check for the Redis data source. I created a private repo on GitHub so we can dump all our code in there and keep track of all the changes that we're making. And Darsh, like you said, it was super easy to password to protect the Redis server, and Grafana was also super easy, but a little different. So I just wanted to let you guys know that's not gonna be a problem. And as far as goals for next week, I obviously want to get that plugin health check issue fixed. I'd also like to create documentation for everything that we've done for setting up the server, installing the modules, and linking to Grafana, because there's documentation for each individual piece, but there's not really a solid start to finish guide on how to do it. And I figured since we're going to be probably doing it on multiple machines for the project, since we're working independently, it would be useful to have it all in one place. And adding onto that, I'd also like to do the same thing with a list of useful Redis and Grafana CLI commands, just because there's a lot of them in a lot of different places, and I think it would be very useful for us to have them all compiled into one place. And I don't need any support right now. One question that I had was, should we be looking into some kind of data shipper to load the information that we get from the inputs into our Redis server, or do you think that we should write a script to do that?
You're saying is the I guess publishing the database point, would it be a separate application, or would it be part of the actual the software, I guess UI software you guys will be writing? Is that the question?
That's the question.
I guess it would be better if you just keep because your application will be another client for a Redis server, because it's going to be two separate things, right? So your application would be client of your Redis server, which will live also on the Raspberry Pi. You'll at the beginning of the software, you're gonna trigger the server, and then you're just gonna, from your application, you're gonna connect to that server and publish the data onto
Okay,
the
so just handle it all
database.
ourselves.
Yes.
Gotcha. I appreciate that.
Okay. For last week, I started with the PCB design, and I worked with the electrical team to find the components, the DAC and the ADC components. We found the breakout boards to test the DAC and ADC components. Also found a way to test the chips if they are surface mount, which is a dip adapter. For for next week, plan to continue research the stepper motor and how to implement it in our design. Also want to continue look for more components that we may update. Also prepare for the CDR. I don't need support, but also I have a question about the stepper motor, like about the specifications, or like if you guys can provide us with a data sheet or specify it.
I think I did send it to you guys, right? Like I guess in right after the kickoff meeting over the email. I can send it again.
Okay. The only data sheets that we have right now are the two sensors.
Okay. I did send the link. It was Dan Foss, but I guess I might not have. Yeah, I'll send it again. Yeah.
Okay. Awesome.
All right. Do you have any questions for us?
No, but I have Pete joined today's call since you guys had question on the digital relay, right? I wasn't even sure how to answer that one, so he has joined to confirm like how that 24-volt AC relay works. So I guess Pete, you can proceed.
Okay, yeah, so the relays don't need to be high voltage themselves if they're the digital outputs or digital inputs, don't necessarily need to be high voltage or AC on your side of the system. We go between relay in our platforms because we are transferring between either AC or high voltage signals, and we need to capture those safely. So if you guys can find a mechanism or a good relay that gives you a wide range of input types or output types that you can support, that's good. But I don't think it's a specific requirement that it needs to be outside of like a 5-volt or contact closure that can manage a reasonable amount of voltage, DC or AC, as a relay contactor.
All right. Thanks, Pete.
Also, there was a question on Discord. Like if you guys can share proprietary stuff. I mean, according to Pete, he said nothing is proprietary, so you can share stuff over Discord. It's fine.
All right.
And,
thanks for that.
Yep. And there was a little concern over not able to do the compute module, but our goal for this year's project is to come up with the compute module design. So I guess our plan is to actually at some point soon we will provide you with a previous project so that you don't run into hiccups and spend more time on something else which is already invented or done by previous team. So you will be expecting those soon.
Got it.
Yeah. So compute module is the way we are going forward.
All right. Thanks for clearing all that up.
Yeah. Any other questions you guys have?
If everyone else is good, I think that's all I've got for now.
Yeah. Would you be able to send either over the Discord or email? Send us the data sheet. Whatever the part numbers you guys have decided you guys want to review, so we can give you feedback.
Yeah, for sure. We can definitely do that.
Yep. Okay, sounds good. Thank you.
All right. Thanks, guys.
All right.
Yeah. Additionally, I know we wait for the with PDR or CDR for review. But if you guys do want to review anything, broader in terms of design, feel free to use us as resources for some of that stuff too. So I think previous groups have showed us some circuit designs or asked for some feedback on certain aspects. So if you do have questions on those fronts, throw them up on Discord and we can try and give you some feedback before the review dates. Certainly don't have to, basically to say, we obviously have to meet those, but certainly don't have to wait necessarily if you need feedback right before then.
All right, thanks for that.
Okay.
All right, if everyone's good for now, I think we can wrap up.
All right. Thank you.
All right, guys. I'll
Thank
talk to you
you.
next week.
All right, thanks.
Thank you, guys.
Thank you.